Alright, this is 1C, Toolkit Functions, PreCalc.
The linear function. The parent function is y equal x.
The graph of a linear function is a straight line, and these are the points shown. The domain is negative infinity to infinity. The range is also negative infinity to infinity. For the parent function, it's reflected over the origin, making it have an odd symmetry. The parent function is not bounded. There are no asymptotes, discontinuity, nor extrema, because it's just an infinite line. For the end behavior, as x approaches infinity, y approaches infinity, and it's written in a function. And as x approaches negative infinity, y approaches negative infinity.
The coordinate function. The parent function is y equal x squared.
Okay. So the graph is a parabola. It has a domain of negative infinity to infinity, and it has a range of 0 to infinity, making it bounded below. The parent function reflects over x equals 0, making it have an even symmetry. The function does not have any asymptotes, and the graph shows no discontinuities. It decreases from negative infinity to 0 and increases from 0 to infinity. And the parent function has an absolute minimum at 0, 0. For the end behavior, as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches infinity.
This is a cubic function. The domain is negative infinity to infinity, and the range is negative infinity to infinity.
Cubic functions have odd symmetry. When you plug in the opposite x, in this case negative x, the function flips. It's not bounded, there are no asymptotes, and there are no discontinuities. It increases from negative infinity to infinity, and there are no extrema. For end behavior, as x approaches negative x, y also goes to negative x, and as x approaches infinity, y also goes to negative infinity.
This is a cubic function as a parent function of 1 over x. The graph infinitely gets closer to x equals 0 but never touches. That is why the domain is negative infinity 0 to infinity, because the x value never reaches 0. The range is the same, but with y values it gets infinitely close to y equals 0 but never touches, so therefore the range is negative infinity to 0 and 0 to infinity, because it never touches the y value is 0.
The symmetry of this function is odd because when you plug in the opposite of x, which is negative x, the value of the function changes. This function is not bounded because the arrows go in both directions. The vertical asymptote is x equals 0. This is because because when you set the denominator equal to 0, you get x equals 0, which makes the vertical asymptote x equals 0. And then the horizontal asymptote is y equals 0 because the degrees are bigger on the bottom, which makes the asymptote y equals 0. There is an infinite or non-removable discontinuity at x equals 0 since the vertical asymptote is x equals 0. This function is always decreasing, but since there is a horizontal asymptote, the 0 disrupts the regular negative infinity to infinity function. The function is decreasing from negative infinity to 0 and from 0 to infinity. There are no extrema in this function, and the end behavior is limit of function as x is approaching negative infinity, y is 0, and as x is approaching infinity, y is 0, because there are asymptotes.
Square root function 101. The parent function of square root function is y equals the square root of x. The graph has points 0, 0, 1, 1, 4, 2, and 9, 3. The domain of this function is bracket 0, comma, infinity, parentheses. The range is bracket 0, comma, infinity. The graph only increases positive.
There is no symmetry and the graph is bounded below and not bounded above. There are no asymptotes. The extrema is absolute minimum of 0 at 0. The end behavior is as x moves positively above 0, y increases.
Absolute value function. The parent function of this function is the absolute value of x. The graph runs through points -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. The domain is negative infinity to positive infinity. The range is bracket 0 to infinity. The symmetry is x equals 0 even, because it's symmetrical along the y-axis.
The function is bounded below and not above. There are no asymptotes and no discontinuities. The extrema is absolute minimum of 0 at 0. The end behavior is as x approaches negative infinity, y goes to infinity, and as x approaches positive infinity, the y goes to infinity as well.
With exponential functions, b is less than 1 means the function is increasing, and when b is greater than 1, greater than 0, but less than 1, the function is decreasing. For example, we have the functions 2 to the x and 1/2 to the x.
The domain for function 2 of x is all real numbers or negative infinity to infinity because there are no restrictions. The range for f of x equals 2 to the x is 0 to infinity because of the asymptote approaching 0. The domain for g of x equals 1/2 over 2, 1/2 to the second is all real numbers because of the no restrictions, and the range is 0 to infinity because of the horizontal asymptotes for both functions is y equals 0.
The boundedness is below because it keeps going, and there is no symmetry and no discontinuities.
The function y equals 2 to the power of x is constantly infinity to infinity, while the function y equals 1/2 to the power of x is constantly decreasing from negative infinity to negative infinity. There are no extrema because it's continuous with no maximum or minimums. The limit of f of x equals 0 as x approaches negative infinity. The limit f of x approaches infinity, or negative infinity, as x approaches infinity. For the function 1/2 to the power of x, the limit g of x is equal to 0 as x approaches infinity, and the limit of g of x equals infinity as the x approaches negative infinity.
So this is a logarithm function. For symmetry, we found it was neither because if you fold it over on itself, it will not be equal. We also know it's not odd because the x and y values don't coordinate at all. This function is not bounded at all because it does not have a max or min hump on either side of the x-axis.
This function has a vertical asymptote at y equals 0 because it never touches the y-axis, and it also continues on all axes because if you were to draw the line representing the graph, you wouldn't have to lift your pencil at all.
As you can see from the graph, the function is going from 0 to infinity, so our increase is 0 to infinity. There are no local extremes on the log function, so the answer would be none. The end behavior of the function is x is going to infinity because our function keeps on going.
Here is a graph of a log function. As you can see, the dotted line represents the vertical asymptote at x equals 0. The domain is 0 to infinity because the vertical asymptote keeps the function positive. And the range is negative infinity to infinity because there is no horizontal asymptote, so the function keeps going forever.
This is the greatest integer function. The equation is y equals greatest integer of x. How you plug this into the calculator is y equals int x, and for decimals you put y equals 4x.
This is what the greatest integer function graph looks like. It looks like a staircase, but on the end of each stair there's a closed circle and an open circle. Another way to think about this is the output is the greatest integer less than or equal to the input. The domain would be all real numbers, and the range can be represented by this z symbol, which means only integers.
The discontinuity is a jump discontinuity, and it is at each integer. It is non-removable. There is no extrema, symmetry, boundedness, or asymptotes.
The end behavior is expressed as the limit of f of x when x is approaching negative infinity equals negative infinity, and the limit of f of x when x is approaching infinity equals infinity. Increasing and decreasing is demonstrated as constant at every step.
This is the logistic function. The equation of the parent function. The equation of the parent function is f of x is equal to L over 1 plus e to the negative x.
This is what the graph looks like. The domain is negative infinity to infinity, and the range is 0 to 1. It is bounded above and below.
The graph has a horizontal asymptote at y equals 1 and y equals 0. There are no vertical asymptotes.
The graph is increasing from negative infinity to infinity. There is no point where it is decreasing.
As the x values go towards negative infinity, the y values reach 0. As the x values go towards infinity, the y values reach 1.
There is no symmetry, discontinuities, or extrema for this function.
We will be using the parent function y equals sine of x.
As you can see in the graph, the waves go on forever, giving an unrestricted domain of negative infinity to positive infinity. The range is usually dependent on the amplitude, so in this case the range is negative 1 to 1. The parent function y equals sine of x is bounded above and below because of the graph restrictions at the y values of positive 1 and negative 1.
As far as symmetry goes, this function is odd. This is because if you were to plug in negative x for f of x, you would not get the original value. There are no asymptotes, and there is also continuous discontinuity. It is also continuous since there are no holes or breaks in the graph.
Okay, lastly with extrema, there is a absolute max of 1 at x is equal to pi over 2 plus 2 pi k, where k is an integer of all real numbers, and an absolute minimum of negative 1 at x is equal to 3 pi over 2 plus 2 pi k. For end behavior, as x approaches infinity, the y is does not exist, and as x approaches negative infinity, the y value also does not exist.
13.